Okay, hello everyone. This is section 3.1 and it's about radian measures. So as you know, so far we talked about angles in degrees, and we worked on these angles, and we found trig functions for these angles measured in degrees. But sometimes in some special situations or applications, we need to use the radian measure. And in this video, we are going to learn how to convert from degrees to radians and from radians to degrees. So this is section 3.1, as we said. Okay. Now looking at the x and y axes, so when we have, in degrees we have 0 degrees. So every time I put this little circle symbol, it means I'm working in degrees. If I don't have that symbol, that means we are in radians. And here we have the 90 degrees. And here we have 180 degrees. And of course 270 degrees and 360 degrees. Okay, so for when it's 0 degrees, it's 0 in radians as well. And when it's 180 degrees, that is the same as pi. But when we are working in radians, pi is approximately 3.14. So if 180 is 1 pi, then 90 is the same as pi over 2, right? Because this is half of 180, which it is again half of 3.14, and that will be about 1.57. And when it is 270 degrees, that is the same as 3 pi over 2. And in radians, that is approximately 4.71. And when it is 360 degrees, that's the same as 2 pi. And in radians, it is approximately 6.28. And this will be here our unit circle. We will talk about this later, but keep in mind that is x squared plus y squared equals 1. Okay, so let's look at some examples when we start converting from degrees to radians. So here we say to convert from degrees to radians. We multiply by pi over 180. Multiply by pi over 180. And we will see that in the next examples. So first one, if I need to convert 45 degrees to radians. So what I'm going to do is going to sketch this little table here. So I have 45 degrees, and I will multiply by pi over 180. And of course I can reduce this to, if you divide by 45, this will be 4. So your answer is pi over 4. So 45 degrees is the same as pi over 4 radians. Let's look at another one. we have 200 degrees this time. Okay, again, take the 200 degrees, multiply it by pi over 180, and this will be reduced to a 9, this can be reduced to a 10, so your answer is 10 pi over 9. We'll look at one more example. It's a negative angle this time, but it shouldn't be a problem. So it's negative 54.27 degrees. Again, we will multiply the angle 54.27. I gave myself a little room here. Multiply by pi over 180. And using your calculator, you will get negative 0.94719. Of course, I use the calculator to find the answer here. Okay, now let's see how to convert from radians to degrees. So this time we'll convert from radians to degrees, and here you will multiply by 180 divided by pi. Okay, so let's look at some examples again. First one, we have 2 pi over 3. So I'm going to multiply that by, so I have 2 pi over 3. I'll multiply it by 180 over pi. Of course, pi will cancel, and this can be reduced, the 3 and the 180, and your answer will be 120 degrees. Okay, let's look at another example. And this time we have 7 pi over 4. We have 7 pi over 4 multiplied by 180 over pi. Cancel out the pi and reduce, and you will get 315 degrees this time. Okay, we'll look at the last one here. And this time I have a 2.12 in radians. See, I don't use the degree sign, but it's the same thing. I will do 2.12 multiplied by 180 degrees over pi, and that will be 121.47 degrees. Okay, so now we learned how to convert from degrees to radians and from radians to degrees. Next, we are going to work with some functions in radian measures. So here, they're asking me to find the exact value. First one, we will work on sine 7 pi over 6. Okay, so this is in radian. In degrees, 7 pi over 6, we said we are going to multiply, to convert it to degrees, we will multiply it by 180 over pi. So I'm going to do it here on the side. 7 pi over 6 times 180 over pi. Cancel out the pi, reduce to whatever you need, and you will get 210 degrees. Trying to see if you can see that. Yes. Okay, taking the, 210 is in quadrant 3. So we'll take the reference angle, and when we are in quadrant 3, we say the angle 210 minus 180, right? And that will give me 30 degrees. So my reference angle is 30 degrees, but I am in quadrant 3. So here is my angle, 30 degrees, and here's my triangle. And this is a 30, 60, 90 degrees, a special triangle that we talked about before. And the sides in this case will be 1√3, and the hypotenuse is 2. But remember, we are in quadrant 3, so this will be negative, and this is negative as well. So what is the sign for this angle? Sine, so I need to find sine for 7 pi over 6, which it is the same as sine for this angle. So 7 pi over 6, sine is the opposite over the hypotenuse, and that will be -1/2. Okay, last example. We have number 2, tangent 3 pi over 4. Again, this is in radian, so I'm going to convert it to degrees. That is 3 pi over 4 multiplied by 180 over pi. Cancel out the pi's. You will get 135 degrees. So tangent 3 pi over 4 is the same as tangent 135 degrees. Okay? Again, 135 is in quadrant 2. We will take the reference angle. And when we're working in quadrant 2, the reference angle is 180 minus 135 degrees, and that will be 45 degrees. So my reference angle is 45, and I'm going to graph it here. Quadrant 2, here is my angle, 45, and this is a right angle. And for the 45, 45, 90 triangle, the sides are 1, 1, √2 for the hypotenuse, and this is negative because we are in quadrant 2. Okay, tangent, in this case, for 3 pi over 4 will be the opposite over the adjacent, and that is 1 over -1, which it is the same as -1. That's the tangent. Okay, this is it for this video, and I'm gonna see you in the next one.